All right, this video is also based off of concepts in 16.3. So there's no direct problems for it other than a review check problem, RC-3. And then we took some problems from 4.3 and we changed the instructions on them to cover the subjective for you, since there were no problems in 16.3 that actually ask you to these exact questions. So we're going to use the discriminant to determine the number type of solution to the quadratic equation here. So let's go ahead and look at this question, and it says decide whether the following statement is true or false if the discriminant b squared minus 4ac equals 0, the graph of f of x equals ax squared plus bx plus c with a not equal to 0 will touch the x-axis at its vertex. Well, hopefully you know what a parabola looks like. The graph of a ax squared plus bx plus c is a parabola that's going to open up or open down depending on the sign of this a term, and it could possibly cross through the x-axis a couple of times, or it may come down here and touch and go back up, or come from the bottom and touch and go back down, something like that. So they're asking if we have this particular situation here where it touches but does not cross, if the discriminant is 0. And that's true, because we only have one solution, one time that it's one answer to where it equals 0, which is going to be its x-intercept. And so that's going to force the quadratic equation, the parabola, to come down and touch the x-axis and turn and go back up. If it was any lower on the graph, if it opens up, then it would cross through 2 times. If it was any higher on the graph than that, then it would not touch the x-axis at all, and it would only have complex solutions and no real solutions. So now let's look at the next question. If b squared minus 4ac is greater than 0, it's a positive number, which of the following can be said about the graph of ax squared plus bx plus c with a not equal to 0? So the graph is going to have 2 distinct x-intercepts, right? If I have for x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, if this part right here, b squared minus 4ac, if it's a positive non-zero, number, it's not negative. If it's negative, I get 2 complex answers. If it's 0, I get 1 rational answer. If it's a positive number here, I get 2 answers here, maybe rational, maybe irrational, depends if this b squared minus 4ac part is a perfect square. If it's a perfect square, I get rational answers. If it's not a perfect square, I get irrational answers. So let's go ahead now and let's look at 16.3 RC-3, which this is a review check problem. And we want to specifically look at the problem 5x squared plus 6x plus 2 equals 0 and decide what type of zeros it's going to have. We don't actually want to find the zeros, but all we need to look at is b squared minus 4ac to decide that. So b squared is going to be 36. AC is 36 minus 40. Uh-oh, that's a negative 4. Right? So it's going to have no real solutions. it's going to have two complex, your book may say imaginary, so complex is the better word, solutions. Okay, so if that number had been positive and a perfect square, then it would have had two rational solutions. If it would have been positive and not a perfect square, it would have had two irrational but real solutions. If it had a number that was, if it was 0 on the inside, it would have had exactly one real solution. But since it's less than 0, it has no real solution. It has two complex solutions. All right, that's it for this topic on the discriminant. And we are going to come back next time and do some instructor created questions. They are not in the textbook at all, but we're going to talk about a really important topic to get you ready for pre-calculus called completing the square and writing the quadratic equation in what we call vertex form. So we'll explain that a little bit more. That has to do with getting the equation ready to graph it using what we call transformations. We're not actually going to do any graphing here in MDE 60, but this is the setup to get you ready to do the graphing in Math 161. So really important topic. You are coming back to this. Don't forget how to do that. Pay real close attention to this next video coming up. All right, we'll see you for the next video.